Hello everyone, Embedded Monkey here. Bought a new cap, by the way. Pretty cool. And today we have Embedded Adventure Day 5 and Day 6, because I missed the Day 5 actually. So as you can see, the last video was 2 days ago actually. Due to my studying and work, I wasn't able to record. But nevertheless, let's make this video longer. I don't know, maybe 2 hours. But I hope we'll cover more. And yeah. And also, thank you to all of you guys for supporting me in comments, in hitting the likes. That's really motivating me for continuing this embedded adventure where I am as complete, absolute beginner in this world of this small, tiny things, trying to do cool stuff. So, without further ado, let's get started. In last series, we actually wrote some code to connect to Wi-Fi. So as you can see, I was instantiating the station configuration, and then I actually made in a very strange way. I tried to I tried to write the SSID and password to the station configuration, and then I just passed this configuration to the ESP Wi-Fi set config, and then we tried to connect, and it occurred that this is actually the wrong way to check it, because I was trying to connect to absolutely random network, and it actually returned me ESP OK, even though that this network does not exist nearby. And the problem was that this function, ESP Wi-Fi connect, so let's check its signature. Let's check it. So by the way, that's why I actually made this clickbait preview that, yay, we connected to Wi-Fi, or have we? Actually, no. Let's see the actual signature of this function. Yep. Here we go. It actually returns the code that tells us either some error with Wi-Fi configuration, or it tells OK when Wi-Fi driver took the task to connect to this access point in its event queue. So it only tells us that it was successfully put in the queue of future events, but it hasn't really connected. So to fix that, I pasted some GPT code, but I will just try to explain what does it mean here. So in the very beginning of this Wi-Fi experiment program, we actually created the event loop. So so we created event loop, then we just continued, but we actually have to make some event handler instance to actually handle the events from Wi-Fi driver. And I actually created an instance that will when the event occurs, it will call this function, the Wi-Fi event handler, where there are, okay, this is a GPT code, right? But let's just try to understand it. So I will understand it too. And finally, I hope we'll be able to connect this thing to Wi-Fi. I hope that we'll succeed in it. Okay, so let's just check the documentation stuff firstly. I found the documentation for the ESP event, and let's just read a little bit about it. So station side behaviors to station. Difference in code, alright. events and event loops. Okay. Case an important occurrence such as a successful Wi-Fi connection to an access point. By the way, I found this interesting that many like this event library basically used just for Wi-Fi. I haven't like seen on the internet any other usage of this library, but probably it can be used for some reason. Okay, two-part identifier should be used when referencing events. Probably I was, yeah, okay. Sorry guys. Mentioned previously, events consist of two-part identifiers, the event base and the event ID. Alright, so the event base, depending group of events, identifies the event within that group. Okay, okay. Seems reasonable. So, that's like a pretty solid approach for rubricating like errors or events. Like I use it in my project in my work when when we were rubricating the errors. Like we also made some structure that has the group of errors and the actual error from this group. So pretty solid. Think of the event base and event ID as a person's last name and first name, respectively. Okay. Let's just see the structure itself. Event base. Oh, so we actually get them separately. Event base and event ID. And only then we compare that event base is actually some Wi-Fi event that has occurred. Then we actually, and then we compare the event ID to the actual ID. Event STA disconnected. Event data. Oh, and we get some extra info here in our event handler. So the event handler gets, well, interestingly, what is arg here? Like I understand what are those. These are just rubricated event identifier, and here's some extra info for it. Reason, okay. Reason, no, fail. Okay. But I guess something wrong here, because how could we disconnect from the reason that wrong password? Like, if the reason is wrong password, it couldn't be a disconnection, because if we have entered like wrong password, we haven't even connected to the network. How could we disconnect? Okay, maybe it's just a mistake. So then if event base is IP event sta got IP. Interesting. Okay. There's like probably some DHCP events here. Not the connection itself, but only when the DHCP server in our network have given the IP address to our ESP32. But okay. So just gonna look here. The event source. Events to the event loop using the APIs provided by the event loop library. And event handler is registered to the event loop, respond to specific types of events. Using the library roughly entails the following flow. The user defines a function that should run when an event is posted to a loop. This function is referred to as the event handler. Okay. it should have the same signature as ESP event handler T. Okay, and the signature is the following. So we have some event handler arg, we have some event base, event ID, and event data, as we saw in my code. Yep. Okay. An event loop is created using event loop create, but we actually have done this with function ESP event loop create default, because just to not specify these stuff, I just wanted to create like that with a default loop handle and default loop args. So okay. Then components register event handlers to the loop using ESP event handler register with. Handlers can be registered with multiple loops. Okay, so handlers can actually react to can subscribe to events from different loops. I guess that's how it works. Post an event to the loop using ESP event post to. Components wanting to remove their handlers from being called, so unregister. Okay. Then event loops that are no longer needed can be deleted using loop delete. Okay. Okay, so I understand a little bit more, but I want to also ask the ChatGPT about this example here. Like, what does the arg filled in event handler T does? Because I don't really understand what is it. Maybe it's the object itself, is like the this pointer in C++ for the particular object of the class, maybe. So arg in event handler is simply a user-defined pointer that you can pass into the event handler when registering it. It has no special meaning to ESP-IDF itself. It exists purely so you can give your handler some context. My data pointer becomes the arg in your handler. Pass configuration. You can pass a pointer to a struct with settings, pass object or class instance in C++ ESP-IDF apps. Pass free R2S queue event group handle so the handler can signal a task. Okay, so it's just basic, some extra user info that we really don't need, so it's null here. Okay. Seems reasonable. Probably, it can be used if we want to somehow call some other ESP event handlers, or we want to put some event simultaneously with calling this handler, or we want, for example, to pass some context there. So if we have something going on in our program and we could have fall into this handler by several different ways, we could pass some context there, so the handler will know from which context we have fallen in it. So I want just to look at this function one more time. So we'll just pass the event loop. The event loop is Wi-Fi event, sorry, what? We should pass the event loop here. That's actually strange. Okay, so event handle loop. Okay, then we pass the base, then we pass the ID, ESP event any ID. Okay, then we pass the. Oh, what the heck? Oh, sorry guys. Sorry guys. Just a little bit sleepy. Then we pass the pointer to the handler itself. No, actually no, because we pass the handler. But the event handler T is actually a pointer by itself, so we don't have to. Wait. Hmm. Yep, it's pointer by itself, so we have to actually make it as a pointer. Alright, then we pass null to this arc thing. Yep. And then we pass the instance any ID. By the way, what is ESP event handler instance? Like, what is it? Event handler to a specific loop. Okay, so event handler instance is actually interesting. What is it? Context identifying an instance of a registered event handler. So that's just basically an object that packs everything up, I guess. Packs the event handler, the loop, and the event. Probably. Okay, so that's a good approach, I guess. But we also should specify the event loop here. So we should specify the loop handle. Actually, we haven't even created it properly. So we should somehow get the event loop handler. Yep. From the default function. Oh, that's kind of forum. Sorry. Let's go here. Okay. Create default. Create the default event loop, and but how to get the default loop handle from there? Like we should specify it in our function, so we should pass the ESP event loop handle, and we just don't pass it properly. So I guess the compiler will be wrong. I guess ChatGPT actually made a mistake here. Like, look, he just said that register, and it doesn't pass anything here. It just starts right off from the event. By the way, let's just ask him, like, why don't you pass the ESP event loop handler, not the handler, but the one moment, handle, yeah, like this thing that identifies the event loop itself, because that seems pretty strange to me. Like, at least I would have passed the null ptr if I sorry, wanted to default it. The assurance, because the ESP32 is a global by design, not per loop, you never need to pass the handle to the handler. No, I actually meant in this function. Yep. moment, guys. It's dumb as shit. Like, why? It's just basically like, it's just compiler incorrect. You just can't. Oh, okay. My bad. This was a different function. Holy moly, I should sleep more. Yeah, we just passed the event base, then we passed the event ID, then we passed the handler, event handler itself, yeah, like the pointer to the function, then we pass arg if we need, and then we pass the instance. Okay, don't give a shit. Okay, so we finally created the default event loop, we registered it, and then all we have to do is compile this thing, I guess, because the connection code is actually ready. But we don't actually need this thing anymore. We don't need it. And the only thing we need is actually... that's all, I guess, because I guess on the hardware level it will call some interrupt, and then this function will be called in this interrupt, and then we'll actually process the event that has came. So currently we have totally unexisting network here. This is actually a password from my mobile network, but it doesn't have a name of A, B, C, D, E, F, G. So let's just try to compile it finally and flash it. By the way, I should connect this thing. One moment. Okay, so plugging it in. Good. So let's now flash it. Flash. By the way, guys, I guess, like many of you interested, how long will I make my embedded adventure? So I guess until I make like at least some working cool project, but maybe more, maybe less, I don't know. Currently, I just want to explore this area deeply. Like I've mentioned in the description and in the very first video, like the day 0. So I mentioned that the first like goal is to just dive deep into this thing, and then to actually make a cool project. So currently we just want to make the simplest, the dumbest project, like just to control the LEDs of the ESP remotely. And that would be actually pretty cool. Then I'll think I have some ideas. One of them is probably to make some kind of like walkie-talkie or radio or something like that. I guess that would be pretty cool. But to actually do this, I have to explore and study more a lot about the microcontroller. So probably it will be much later. Okay, so server started. Scan the networks. And we haven't connected. Disconnected, reason 201. Actually, it would be pretty cooler that we would output not the code, but the actual reason, like in text or something. Well, I will just see, maybe there's some functionality to access the to just access the maybe an error message or something like that, not just the error code here. Stop. I'm getting ill. I actually hope that I'm not, but sneezing. Okay. So the reason is actually a uint 8t code, and we don't have anything else, right? Okay. So let's now try to connect to an existing thing. I'm just gonna turn on the hotspot on my phone, and we'll try to actually see the IP address, the MAC address of the ESP32 from my phone. Yep. So here is the name of it. Here it is. So I guess I will just retype it here. The password is the same. Yep. I hope you guys won't steal my password. Okay, so let me check once again. iPhone. Okay. So currently it's on. Let's try to compile it once again. Yep. Let's compile it once again. See what will happen. By the way, I haven't actually written anything about theory here. As you remember, like in the very first video, I have mentioned that I have some theory notes in my Google Drive, so probably I should make some notes on this weekend. Today is like 6th of December, Saturday, so I guess I will cover some topics by myself and upload them here. Probably I will notify you guys in my Telegram channel if you subscribe. I haven't really saw if anyone has subscribed there, but okay. Okay, so let's now monitor it. So the Wi-Fi service started and disconnected. We haven't actually connected to this network. Then why? Actually not very cool. Yeah, I haven't seen actually any of device like that's connected to the hotspot. So probably we should Google this reason. Maybe the password. Actually no. Actually the password was correct, I guess. Okay. Let's Google this. So the reason 201, meaning of reason codes. Yep. So 201, no AP found. By the way, our good old friend, our good old friend from the first embedded series, Colbin from Texas, helped me a lot actually to code with a ESP-IDF. Yep. So the reason is it probably does not see this hotspot for some reason. Okay, seems reasonable. So it can actually it can only connect to the APs that it has seen, probably. Okay, let's try to connect to this network. I actually know the password. because it's my network. I haven't installed any password in my life. Okay. Let's try it out. Okay. As far as I know, let me check. By the way, I think I could have forget it. Okay. Okay. So I actually remember it right. 140009. Okay, okay. That's okay. Let's compile it once more. One more, David, one more. Yeah. So, by the way, that's not the ad of Vodafone. Like, I just bought this cap in Turkey like 2 years ago. I don't know. Just seems pretty cool. Okay. Just a random fact. I don't know if you guys like it. Okay, let's flash that shit. Monitor. Okay. Service started. So we scanned the networks. It does not see the AP. It just don't seem to actually locate the AP. That's actually strange. By the way, probably I know why. So I haven't actually changed these ones. Oh my gosh, bro. Oh, hell no. Whew. By the way, I could have actually make the just interesting, because I'm actually interesting about compilers too. So will it work like this way? Because then we don't need this thing. Yeah, we only will need that the STA configuration, like SSID is equal to the network name. Yep, so the pointer itself, because we need the pointer there. Well, probably it won't work because we can't just plainly. So if we want to change the pointer itself, we need the pointer to pointer, and here we got only the pointer to the array itself. Yeah, so just a quick reminder for what I have struggled in previous series. Like, let's see here. Here we go. These are the static arrays, not the pointers. So we can only access these elements here. That's actually pretty dumb, but okay. So I guess the only way to do this is actually to just make it in a for loop. Okay. So here we have the 1, 2, 3. Oh, hell no. I'm mistaken in the name of AP itself. forget everything that I told you guys. Okay, so we got the Sunshine network. We got the 140.0.0.9 for team of 22.75. Everything seems to be okay. Probably can actually 32 64. Okay, let's try again. Seems like I just have a mistake with the AP name itself. Okay, can be the reason. Let's check a little bit more info about the events. Yep. Where? Oh, here it is. So, the event consists of two parts: in the event base and the event ID. Identifies an independent group of events, and these the group. Think of the event base and event ID as a person's last name. To declare and define the event base easily. So does it mean that we can actually define our own events or something like that? Seems pretty cool. Okay, so we flashed this. Let's monitor. Okay, so the servers have started. Scan the networks and for absolutely no reason. By the way, I guess we don't really need scanning anymore. That was cool, but I guess we can actually delete them here. For now, just to not take a lot of time when monitoring. Yep. And maybe that's because I haven't null terminated. That's why, maybe. Yep. The other reason could have been because maybe it stores not the network name itself, but there's some hash of it. I don't know, I just want to think a little bit in silence. By the way, interesting. Why is it not good practice to call ESP Wi-Fi connect after ESP Wi-Fi disconnect? That's interesting. Why it's not a good practice, okay. Looking at the Wi-Fi versioning example code and no ESP Wi-Fi connect. SSID of target AP, password of target AP, scan method. Maybe the scan method, maybe I should change the scan method here. Well, actually, I guess that doesn't really matter here. BSS ID, so whether it's at MAC address of target AP or not. Okay, target AP. But we shouldn't really specify all that stuff. I guess it should work just with basic config. That's okay. Oh my gosh. Oh, let's see. .sta SSID password. Set config. Actually, I have set the config here. Yep. So okay, so here I created the STA configuration as a separate one. Then I just the mode. Okay. Then I just like fill it with some with my data of SSID and password. Here. Maybe the method is wrong here, because everything else seems to be okay. So we set the mode to Wi-Fi mode STA. Yeah. Sorry guys. Okay, so one moment. Here we set mode. Okay, but I have set the mode of STA like long before. Here we go. Wi-Fi mode STA. Yep. So in ESP Wi-Fi set config, I should only set the ESP Wi-Fi start. So you mean like... So I should have called it before the start method. Well, maybe. So we pass the Wi-Fi if STA. Yep. Then we specify the network configuration data. Actually, I had a problem with this one, but let's just make a default here. Okay, so let's try to start the service after specifying all that stuff. Yep. And we won't even try to connect. Like, will it connect automatically or no? Let's figure this out. Probably that makes sense, because if we haven't set the configuration, like if we updated the configuration, we should at least restart the driver. Maybe it loaded it in some. Okay, like let me specify this moment. Like if we updated the ESP Wi-Fi configuration, should we restart the Wi-Fi service? Like, where does the configuration data is stored on ESP32 Wi-Fi configuration? I understand that it's stored in some kind of non-volatile storage, as I had read about non-volatile storage a few series ago, so probably it will tell me something of non-volatile storage here. The art of how ESP32's driver is actually should let bring. Not in flash, and even not in non-volatile storage. The ESP32 Wi-Fi driver stores all configuration in RAM inside the Wi-Fi driver internal context created when you call init. Contains all dynamic Wi-Fi states. This context is destroyed when you call RAM as part of the driver, not in persistent memory. If you reboot, you lose all settings. If you denit the driver, you lose all settings. If we update Wi-Fi config, must we restart Wi-Fi? Stopped. No need to restart. Is applied before the driver is running. Oh, so we need to stop, then set config, then start again. That's what I meant. But that it's stored in RAM, it's actually interesting. So all the SSID, all the passwords that we have specified, they're actually stored in RAM. They can be they just exterminated when I press the reset button. You must restart Wi-Fi. You must restart Wi-Fi. Restart Wi-Fi now. Now. Let's go. Restart your freaking Wi-Fi. Okay, let's see. Let's see. But I guess it shouldn't automatically connect. Like, the only thing it does, it just starts the service. It does not connect until we set it to connect. So we just will wait for 20 seconds and then quit. Here we go. So probably GPT made a mistake here, so let's just actually obligate it to connect. So to clean this up, what we have done, we needed the NVS flash. That's actually interesting, because I don't really know why should we actually, like, why Wi-Fi driver stores something in NVS, like non-volatile storage, like the most non-volatile thing on this microcontroller, and the basic Wi-Fi configuration, it stores in RAM that can be resetted by a click of the button. It's just pretty strange to me, but okay. Then we created an event loop, then we registered that thing, then we create the Wi-Fi init config here, like we set the mode. That was, by the way, the init configuration. I guess this is a different thing, or no, or maybe I don't get it. Let's just see. like, what is it? I guess it's more like more low level stuff where we specify the buffer size and all that thing. Not the... So this config is a low level config. It's like the RX buffer size, the maybe different supported protocols and so on and so on. It's actually stored in the NVS flash. So it's stored in non-volatile part of memory. And the Wi-Fi config that stores info about the SSID of Wi-Fi network, password, etc. It stores in RAM, and it can be reset easily either by API or by reset button. So that's like two completely different types of config. They are responsible for different purposes. Okay, so I got it. Okay. So here we go. We set the mode to the station mode. Then we create the RAM configuration of Wi-Fi. Then we set it, and then we finally start it. And then we try to connect. After we try to connect, we actually stop. And then denit. In this correct order. So let's try once again. Guys, I just hope we'll be able to connect to the Wi-Fi with the ESP32. That's just like the first thing that we have to do, at least to. By the way, I have broken the breadboard, I guess. No, actually, because I haven't touched the breadboard in ages, like for, I don't know. The last series with breadboard was the second series, so I haven't touched like 4 days or 5 days. That's horrible, man. That's horrible. I want to do some physical stuff again. So let's monitor. Okay, it resets. Service started. Fuck you, man. What the fuck? Oh my goodness. Oh, shit. Damn. Okay. Maybe we should try to look at the example. Just a little bit. Just a little bit. Seems like a good idea. Just kidding. Let's continue to fuck around with this with this stupid code. I can't imagine like what is wrong here. Like I have done everything. Okay, so let's just refactor it first. Okay, so hello monkeys, thing is absolutely necessary. The code won't work on your ESP32 if you haven't wrote this. If you haven't wrote this, your code is absolute failure, bro. So write the hello monkeys from the start. So next section is the initting of some system shit. So the non-volatile flash. Yeah, so the flash and the non-volatile storage. Then we need some network network, I guess, stack here. And then we create the, okay, so here we go. System level level stuff. Then event loop and handler. Yep. So then we actually created the what have we created here? we have created the what it does. Like, I don't understand anymore these things. So this is just an initialization of NVS partition that should be, because some Wi-Fi configuration is stored there. Alright. Alright. Okay. Let's now check this thing. What is this? Is it absolutely necessary? Okay, so this is actually this is for real. This is a stack, TCP/IP stack initialization. Yep. Okay. Network interface handle. What is it? What is it? The ESP-IDF. There is twofold. It provides an abstraction layer for the application on the top of TCP/IP stack. This allows application to choose between IP stacks in the future. The APIs it provides are thread safe, even if the underlying TCP/IP stack APIs are not. Okay. Okay, so this is needed for stack initialization. All right. Let it be. Then we create the default event loop. Then we just register the event handler instance. All right. Event loop and handler instantiation. Okay. So when we create what default Wi-Fi STA, so what does this thing does? Okay guys, I think I should take a break. Then return for next. Oh my goodness. Yeah, let's make a break. And then I'll return for, I don't know, maybe half an hour, maybe 40 minutes more. Because this box really gets me. I don't know what to do. So I should just take a little break here. And then, okay, let's just time about it. Like 5 minutes. Yep. I guess that would be enough. They would be enough here. Let's go. Oh my god. Okay, I'm back with some cup of water. You know, guys, the number one thing is consistency. And I hope that if I will continue doing this every day, I will eventually become an embedded specialist. Yeah, it may seem like very funny, like some random dude tries to do some stuff for 1 hour a day. Uh, Nothing actually works. So no Wi-Fi connection, nothing works. And you know, in that moment you just have to continue. You just have to continue and believe that eventually it will pay off. So, with this said, let's continue fixing that fucking bug. I hate this. Man, I hate this. Why doesn't it work? So, let's analyze it, continue analyzing that stuff. Okay, so we stop at this moment, at this function. Yep. One more time. But you know what? Like, let's analyze the reason here. What have it said? It said that the disconnection reason was 201. Okay, so let's go and see the reason 201. What does it mean? No AP found. Okay. Did somebody had the same reason? Yes or no? By the way, can we get the configuration? Well, I hope we... By the way, you know what? Remember that arc field in event handler? Yep. I guess you guys have remembered that. The arc thing. So we can actually pass there anything we want. And I know the good idea. I know the best idea, probably. Let's just put there the configuration itself. Yep. Well, this is actually probably not the best idea, but it will give us the good thing to firstly, let's check that example with the with the configuration. Where was it? Not here. One moment. Okay. Stay healthy, guys. Just a quick reminder. So, okay. So they initialized the underlying the NVS flash, and then they initialized the TCP/IP stack. Then the event loop was created. Then they created the default Wi-Fi ST. So maybe the order matters. Well, actually, I created the default event loop before the Wi-Fi STA2, so okay. Then what? Then they creating the default Wi-Fi in it. So do I, so I just haven't specified anything special here. But the mode... Oh, okay. Then I set the mode. And then I set the config. So, actually I'm right. I'm right here. Yep, configuration, STA configuration. Here we go. So, instance register. Interestingly, they register events only after the setting config. Probably does not really matter, but okay. By the way, we could have actually made a null here. Yep. It's not really necessary to just specify something here. Okay, just put null here, and it should work. We should just specify the handler itself and the event that we want to catch. Yep. So by the way, let's output some disconnection info. Yep, that's a good idea too, to just make this debug a little bit more informative. Can we just extract something from this structure? We can extract actually SSID. We can extract the BSSID. I don't know what is BSSID. Like, what is BSSID? Basic service set identifier. It's unique address of a Wi-Fi, which essentially is okay. So it's MAC address. Okay. All right. So let's disconnect it reason. So the SSID, let's go. So for int I 0 I is less than the okay, so the disconnection dot SSID lang, I guess it was called something like that. Yep, SSID lang. Let's go. So yeah, and just we'll print the disconnection dot SSID from I. Okay. We should actually specify the format here. Guess let it be like char. I don't know. Then print. Actually, it's uint8, but uint8 and char are basically the same thing. But well, char can be actually interesting. Like, char can char be negative? Char. Oh, actually, it's supported availability. One moment. Can char in C be a no, be negative in C? If the char I would sign. Well, yeah, of course, there is such a thing as an unsigned char, but unsigned char and unsigned int 8 are basically the same thing, because char is also 8-bit. It's basically a byte value. Well, we won't be able to decode it probably, but nevertheless. So the SSID, and let's also output the MAC address. I will just copy the my perfect BSSID output. I know it's perfect. Okay. Oh my god, where do you misclicked? Yep. Here we go. So for the MAC address, well, we actually need just one print here. We don't need the for loop. Okay. So the MAC address, and we'll output the BSSID, but the BSSID from diskin. Yep, diskin. Let's call it diskin. Oh shit. Like, okay. I hope this debug will help me a lot. I will find out at least something similar to the by the way, let me check one thing before I continue. One moment. Okay. Let's continue. So we got the MAC address here. Let's continue that stuff. Basically, that's it. Let's just output this info for now. Let's just flash. Let's see. Yeah, it's pointer. Sorry. Okay. Oh, hell no, man. I have to do it now here. By the way, they could have done a macro to output this MAC address in a fancy way with 2 dots between every of these 6 octets, but okay. Let's flash it. Let's flash it. Stay healthy, guys. Just a quick reminder, stay healthy. Drink water. Drink water, train your brain, train your body. Yes, just a quick reminder. We have to remind ourselves about it every day. Yep. And also have to code every day. Okay, let's go. So the SSID is actually fine. Sunshine, that's actually okay. But it says that SAEPWE value is invalid. I guess that was the error that we have fixed with this line. Let's fix it once again. Flush. Okay. By the way, I don't know. Yeah, it probably can be done like in a bare metal approach, but I would probably die if I would do this in a bare metal way, because bare metal code is actually scary. And these videos would basically be me reading data sheets and instruction manual, etc. Okay, so let's monitor. Let's go. Okay, no error for now, but we're getting the SSID sunshine. Yep, so that is correct. And we get the 0 MAC address, so it doesn't really see this, the network. Okay, but it got the SSID correctly. At least it got it correctly. So, any more info in disconnect structure? Let me take a look. Reason RSSE. What is actually the RSSE? I wonder. received signal strengthening a measurement of the power of wireless signal received by a device. What can it tell me? I don't know. Disconnect. Reason 201. Damn, I like this. I love this guy, man. What a brilliant gentleman here, answering all the questions. Let's take a look at his answer. Damn, Colburn from Texas, the best ESP32 programmer. The messages tell me that the ESP32 is attempting to connect to an access point and is failing to connect. Since it didn't connect, it won't be allocated an IP address. If it were me, I'd investigate why it failed to connect. Then the state disconnect. It likely includes some reason codes possibilities. The access point you're trying to connect with isn't running. You're supplying an incorrect password. Actually, no. So the sunshine. Let me check it by myself. Okay, so the sunshine. Yep, the name is totally correct. The HCP is automatically assigning the IP addresses, so everything is okay. Well, I can't really see the password in my settings, only on the phone, but I compared and okay, you know, for to be sure, 100% sure, I will copy the password literally from my phone and drop it to the computer, and I will just copy paste it. Maybe I don't know, I misclicked something. Can be the case too, just to exclude these dumb reasons. So yeah, let me just open the Telegram. By the way, subscribe to my Telegram channel, guys. Subscribe to my Telegram channel, link in the description. Posting there some materials. Okay, let's now. Nothing changed here. Nothing. So the password is 100% correct. There is a coding error in the parameters that you are using to construct the connection options. Already checked a lot, but we'll consider this reason. The access point has become confused, rare, but seen. When you connect to an access point, the access point knows your ESP32 by its MAC ID. Some access points can get confused thinking that they already have a connected device by that MAC, or that MAC has been disallowed because of some firewall or other rule. A reboot of the access point may be worth a try. No, we won't go this way. You know what? Let's do this monkey way. Let's just ask our biggest teacher out there. the chat GPT. Can you look and say what can be the problem of disconnecting from network with reason 201? Because I'm just running out of ideas. I'm just running out of ideas completely. I'm desperate. Instead of case causes code, I can tell you exactly why it's happening. Yep, I have already read that Wi-Fi reason no AP found is 201, so I already know that for some reason it doesn't like know the what is the Wi-Fi AP. It can't identify it, meaning the ESP32 did not see any exploit matching the configured SSID during active and passive scan phases. This is not wrong password, handshake failure, timeout. Wrong password, handshake failure. It means ESP32 could not find a Wi-Fi network with SSID Sunshine at all. Is typed wrong, most common. Then you copy all 32 bytes. Random garbage. Because ST configuration was never zero initialized. Well, that's also could be the reason. It's usually zero initialized, but oh man, I just hoped it was zero initialized, but let's just try. Okay, let's just try. I hope it will. Well, the only thing we actually need is just to make the following sta configuration dot ssid. We basically zero initialize the SSID, and then we basically initialize by zero the password. Static arrays, and it should work. It should work here. Dang. I guess I understood. Huh. We should actually we shouldn't actually use the 32 one here. Let's just, well, I'm just too lazy to actually count this thing every time. So basically I would have actually make it as a const char. Yep. Let's make it a const char here. Const char. Here. Const char, of course. Yep. The network name. Here we're gonna have the const char password. Yep. And then we'll successfully copy it to the one moment. Just gonna look for the memcpy. I just haven't used this function for ages actually. Let me see. So we got the size and just gonna memcpy open that. Yep, the Russian website, the best one. some noises there. So distance, source, and how much to copy. That's what we need to know. Okay. So, and what should I include? The string hash. The string hash. Sorry. Just trying to hardly pretend that I'm not Russian. Yep. So memcpy to the sta configuration .ssad. Then from the network name, how much? Oh my god. Actually, the sterlan from the from the network name, yep. And here the password. Well, it can be the reason, but we hope that will help. Okay, so we copy these things here and hope that it will actually help. To verify it, I will actually output all those arrays. Let's just make a verification step to actually feel confident that there is no garbage there. Yep. Let's go. Print these things here. Okay, so these are SSID from I. Yep, and let's just output as the %char. Yep, no, let's output as %d actually. Yep, as %d. And the same thing here. Okay. Oh shit, that's not a Vim. I should install Vim, by the way, here. A Vim extension for VS Code, because I'm very used to Vim. Password. You right. Password here. Let's compile this. Flash it. Typo, okay. Things getting really interesting. Network, where? Oh, here we go. Compiling again. Back to the expression before. What the? Oh, yeah, I got this for structure initialization thing. I forgot the C completely. I have to actually get some, I don't know, recap course of C to actually a little like refresh my knowledge because I haven't programmed in C in so much time. Initialize static C array with zeros. Like not dynamically. I know how to do it dynamically. I just want to actually zero fields. It doesn't work that way. It doesn't work that way. This compiler doesn't know that way. It doesn't work that way. Yep. So that's actually not cool. Not cool. This is initialization. It has already been initialized. Okay, you know, let's make it the dumb way. Let's make it the pretty dumb way. The dumbest way possible. Like, I don't know what can be more stupid than that. Let's do it this way. Because every normal compiler just would have actually expanded this rule, but here we don't have actually any of these cool features. Perhaps there are some reasons for it, because this is a compiler for a microcontroller, not for a regular PC, so maybe there are some different stuff going on under the hood, so yep. Let's flash it, flash, please, do it more quickly. Here we go. It's compiled. Now we'll see, is it the really the issue or no? Okay. Monitor. So here we go. Sun, shine, then zeros. Here we got the password. Here we got the zeros. And no, we still disconnect. We still disconnect. There is no random crap there. ChatGPT, you are actually doing something wrong. Yep. Wrong frequency and band mismatch. Wrong country code. Maybe, I don't know. By the way, there could be a reason with the authentication here. Because I put the WPA3 SAE PWE both, so it supports both handshakes, but I'll just check the from my computer here, like what actual what actual type of security does my network supports. Like, let's check this out here. Wi-Fi. Okay. WPA2 actually, personal. WPA2. Let's Google this. Okay. Come on, bro. Come on, bro. No, I can't really click on it. I can go here. Here we go. Let's go here. Only WPA3, no WPA2. That's actually strange. ESP32 WPA2 personal. WPA2 personal. Okay. Wi-Fi protected access 3 is a set of enhancements of Wi-Fi access security intended to replace the current WPA2 standard. It includes new features and capabilities that offer significantly better protection against different types of attacks. It improves upon WPA2 personal following ways. Following additional certified. But actually does not support WPA2 anymore. So I have a very old Wi-Fi, I guess. Okay, like WPA2 personal support. Okay, let's ask GPT. Guess I fucked the context off, but nevertheless. Does ESP32 support WPA2 personal? This is one of the most commonly used. For WPA2, I don't need anything special. So why would it just tell me that I'm wrong and that I should like specify this thing here? That's actually very strange. Flash it. Come on. That's very unusual because like it just tells that I have some error with WPA3 and my network doesn't support it. My network only supports WPA2 personal. And ESP32 should support WPA2 because WPA2 is like a standard, like mostly everywhere, as far as I know. Let's go. Let's go. Okay. We'll catch the error here. And still disconnected. Isn't valid. Why? Like, I don't want to specify it at all. I want to specify just WPA2. Like, there are only WPA3 options that I'm not interested in. I want to... Well, we actually can set to unspecified here. What if we set it to unspecified? Like, it can use anything but WPA3. Will it work? Yep, and let me just, while it's flashing, I'm just gonna check the random nerd shit, because they have pretty good guides. Maybe they have some explanation here. Or they will simply use the Arduino IDE. Well, let's see. Soft AP. They are using a completely different API for connecting, so probably that won't work for pure ESP-IDF. Yep. Flashed monitor. Same reason. Okay, so let's just give up. and see what the example says. I'm just tired, guys. Let's go. Let's go, man. Let's go. Embedded adventure. No, I need actually expressive. Frameworks. Let's go here. Let's go to examples. Let's now go to Wi-Fi. ESP now, fast scan, getting started. Okay, roaming scan, smart config, enterprise NVS config. Getting started. Yep. Let's just soft AP. No, let's just open the station one. Station example. Open. What the okay. ESP Wi-Fi. Okay. What? Okay, alright. ESP Wi-Fi connect. Ding. Wi-Fi event. ST. Start. ESP. Wi-Fi connect. By the way, they are using this thing to actually connect to Wi-Fi, so they don't call it manually. Okay, and what have they specified here? So they have a Wi-Fi config, so they have an SSID, Wi-Fi password. Auth mode threshold resets to WPA2. It's default if password matches WPA2 standards. If you want to connect the device to deprecated WEP, WPA networks, please set the threshold value to this thing. ESP Wi-Fi SCA mode. What is that? What is that? Hunt and pack. Okay. So it's actually something out of these ones. Okay. Identifier. Interestingly, they specify some other options here. But the interesting thing is this one, ESP Wi-Fi scan auth mode threshold. Like, that's where I can actually specify the WPA2 thing. I guess I would like to specify this thing. Let's just see the I guess there should be some more info here on this topic. So we got the scan method and threshold. When scan threshold is set, only APs which have an auth mode that is more secure than the selected auth mode and a single signal stronger than the minimum RSC will be used. So probably it can't really find the my AP because the threshold is incorrect. It just doesn't get into the list of APs that are correspond to this threshold of authentication security. The minimum RSC to accept in the fast scan mode. The weakest auth mode to accept in the fast scan mode. Note in case this value is not set and password is set as per WPA2 standards. it will be defaulted to WPA2 and device won't connect to deprecated networks. Please set oath mode to. I don't actually know whether my WPA PSK shouldn't actually specify this thing here. Like, it will default to the WPA2. And my network does support WPA2. WPA2 personal. That's pretty strange. Okay. That actually gives a lot of information. Let's just set those values before starting the Wi-Fi service. So let's put here both for maximum compatibility. Threshold dot threshold dot auth mode. Yep. Scan mode threshold. Let me check. I guess I would pick something like the minimum, like the bare minimum here. Just like that. And another thing here, I guess, identifier. What does that mean? Password identifier. What is password identifier? What? 2 passwords? SP Wi-Fi PWID. Config ESP-PWID. Where is it? Okay, where is this thing? Can I access it? No. Guess no. ESP Wi-Fi PWID. one more thing to check before I end the video. What is this thing? I won't specify it. Fuck it. So I will only specify this thing because this is really important. It will not find any networks that have lower auth threshold. Yep. So let's put it here. And we'll get rid of this one. Only leave this one and leave this one. Okay. So let's try one more time, and I guess that will be it for today. Damn, almost 2 hours. Holy shit. Day 5 and 6. Yep. Combined. You know, guys, I've already talked today about consistency, but I guess the consistency means like if you like plan to do 1 hour a day, you just have to do no less and no more, and then gradually upgrade upgrade this. So this will actually help to not to burn out on this journey. But actually today I just compensate for the last day because, you know, guys, I just completely messed it up yesterday. I just woke up very lately and I haven't been able to record. Okay, so monitor. Okay, nothing worked. Probably, guys, I will be trying to fix this thing. Maybe there are some easier ways to do this. I hope I will find some materials maybe and well, first of all, I'll upload this code on my GitHub repo. So if you didn't know, I have a GitHub repo that I'm actually uploading all the code that is written here. So we are doing Wi-Fi experiments, so this folder will be updated today, right after video. Also, I probably will try to fix this bug on my own if I'll have time, maybe tomorrow morning before the recording another embedded adventure day. Yep. So I will upload code here, maybe post some materials on my Telegram channel. So guys, if you didn't know, I also have a Telegram channel. Yep, I will just show you it now. I don't know, guys, if you like use Telegram or no, because you know I'm just from the country where most of the things are banned, so we don't have Instagram here, we don't have Twitter here, so I just have a Telegram channel. You can subscribe. I post some materials here. Well, for example, this video I found very useful. This video is also cool, so subscribe if you want. Yeah, and tomorrow I guess I will fix that bug and learn how to actually send and process HTTP requests on these ESP32. And I hope we'll succeed with it. So stay tuned, guys. Stay healthy. I don't know. Hit the like if you enjoyed this video. If you have watched so far, leave a comment if you want. Like maybe I will be glad to answer all your questions. Yep. So see you soon. See you tomorrow. Bye. Okay. Now, you know, let's just get to the 2 hours. Get to the 2 hours. Yeah. That would be super cool. 3, 2, 1. Okay, 2 hours. See you tomorrow.